So we're going to look at something that I'm calling more complex areas. So we've done areas of circles, quadrilaterals, triangles, regular polygons, and now we're going to be looking at things that are a little more complicated. And so what do I mean by more complex? Well, we're going to do three examples together. The first one, let's draw a trapezoid like this. 20 is on top, 25 is on the bottom, and we have 13 on the side. Now someone might just automatically go into that and start calculating area with 13 as the height. But remember, this is the slant height. So we can't use that for h. But I'll still write b1 plus b2 divided by 2 times h. The problem is now we have to figure out the height. And I drew it here because if I drew in a height, that's actually a right triangle. And we also know that in the right triangle there, the hypotenuse is 13, and we actually know how wide this is. Because the bottom base is 5 bigger than the top, we know that that's going to be a 5 down there. So I have to go to the side here and calculate using Pythagorean theorem. So a squared plus b squared equals c squared, and I don't know the height. The legs, A and B, are the ones that touch the right angle, so it's going to be 5 squared plus h squared equals, and c is 13 squared. So I would go to my calculator. It'd be 25 plus h squared equals 169. Subtract 25 on both sides, so I have 144. And then to get that h alone, I have to square root. So h would be 12. It's not always going to come out that nicely, but here it is nice. It's just an even 12. So now we know everything we need. We have our base 1, we have our base 2, we have our new heights, and so let's plug that all together here. Base 1 and base 2 would be 20 plus 25 divided by 2, and the height would then be 12. So one thing about this I want you guys to be careful about. This, when you put it in a baby calculator, things can get kind of messed up because of this part right here. So on your calculator, you need to do 20 plus 25, hit equals, make sure that you see 45 there, the sum, and then divide by 2, then times by 12. So I'm getting a total area of 270 some units, they didn't tell us, squared. Okay, so let me show you what happens if you don't hit enter after adding. If I do 20 plus 25 divided by 2, oh, I guess it does. In this particular calculator, it works out just fine, but I'm just warning you to take your time when putting it in the calculator because it doesn't do PEMDAS for you. So doing it in parts and writing it down will help you out. All right, so that was example 1. Here is example 2, which is a little bit trickier. All right, we're going to have a circle, and inscribed in the circle is a regular pentagon. All right, and what it does, they would tell you that from the center out to the edge is 25. That's called the circumradius because this is a circumcircle. It goes around the regular polygon. But the important thing is that if you go from the center to the edge of a circle, that's your radius. And the question they're going to ask here, what is the area in between the regular polygon and the circle? So here's the strategy. Here's what we want to do. We're going to do the area of the circle, and we're going to subtract the area of our polygon. So we find the area of the whole circle, we take out the polygon in there, and then we just have these things left inside or in between the two. All right, area of the circle is not bad. It's pi r squared. Area of a polygon is 1/2 your apothem times your base, or your base side, times the number of sides. And we can fill in almost everything 25 squared. The only thing we don't know right now is our apothem. You might be tempted to say 25 is your apothem, but remember your apothem goes straight down to the side and makes a right angle with the base side. So what we have here is actually a right triangle that we can solve. Oh, I'm forgetting to give you guys one important piece of information. The base side is 20.2 units. Okay, so I'll leave A alone, then I'll put 20.2, and then there's 5 sides on a regular polygon. So I have everything except for the apothem. If I can get the apothem, then I can start calculating. So this shape right here that I'm outlining is a right triangle, and that's important because then I can use Pythagorean to find the apothem. I need to know the A. So this is 25, this is A, and remember, this is only half of 20.2, so this will be 10.1. Okay, and so we gotta step aside and use a squared plus b squared equals c squared to figure out that apothem. But you've done this a couple of times. The A is gonna be, you could just keep it as A, B is gonna be 10.1, and C is the 25. Because A and 10.1 touch the right angle, they're the ones that have to be on the other side. All right, so A squared plus, and I'll go to my baby calculator here, 10.1 times 10.1, 102.01. And I know from experience, 25 squared is 625. Okay, cool. I subtract 102.01 on both sides. So let me do that here. 625 minus 102.01. That's 522.99. And then I just have to square root. That will get my A alone, and I'm getting 22.8689, blah, blah, blah. But we round to the 10th, so I'm going to write A equals 0.9, 22.9. All right, so remember, we have to do this sometimes. We have to figure out our apothem. But that's not bad now. I can go here, and now instead of A, I can plug in my apothem. So actually, why don't I erase this and sneak in 22.9. All right, so the area total is going to be my circle. Let me figure that out. 25 times 25 times 3.14159, 1963.5. Now on the other side, I have to figure out the area of the polygon. 0.5 times 22.9 times 20.2 times 5. 1156.5. All right, and now we just have to subtract. So this would be 1963.5 minus 1156.5, 807. Okay, it was a lot of work, but if you write things like this, that helps you kind of figure out what formulas you have to use. And then you fill in everything you know. Like at this point, we had to stop for a second because we didn't know A, but we could then go figure it out. So please, please, please write out everything you know and all the formulas you know. So I'm going to give you one that you should try in your notes. So I'm asking you to pause the video, and then after you're done or you're stuck, you can come back and check to see how we did this. Here is the problem. We have a square that is 10 inches across, and we inscribe a circle in there. So we want to know what the area is all around this circle inside of the square. All right, now would be the time to pause the video and then try it out. Okay, the area is, well, we got to figure out the area of the square and then subtract the area of the circle. So the area of the square we know is going to be the side squared. the area of the circle is pi r squared, and so side squared would be 10 squared, and we just need to figure out the radius, which might be kind of tricky to think about at first. But if you think about it, this circle is 10 wide. So at the center, if you go from the center out, it's got to be 5 inches wide as a radius. So this would be 5 pi 5 squared. All right, so the area is going to be 100, because that's 10 squared, minus, and I know 5 squared is 25, so I'm just going to write it as 25 pi. All right, let's have the calculator do this. 100 minus 25 times 3.14159. Now see, this is the issue where PEMDAS is giving us a really weird answer. 25 times 3.14159. There we go. It's really going to be 100 minus 78.5. Okay, so how did I know it gave us the wrong answer? Well, it gave us an answer of 200 something, and I was thinking, wow, if we're subtracting, 100 minus something should be less than 100, right? So the area is just this. What's 100 minus that? 21.5. Okay. Cool. So again, please make sure you get a general strategy. You plug in the formulas, then you plug in what you know and figure out what you don't know yet, and then start crunching it in your calculator.